In this video, we'll take a look at a slightly more advanced topic, and that is how you can go about specializing DDC scripts for a particular controller. Now, out of the box, DDC will work with virtually any controller. You simply have to set the controller up just as we covered in a previous video. However, many controllers have special controls and/or functionality, and we want to be able to make use of that in our DDC scripts. So that's what we'll cover in this video. All of the files that I'll be showing you are available from the miscellaneous folder on the repository. And all these files come with instructions on how to use them. In general, though, you'll have to import them in order to use them in DDC scripts. And that's very easy to do via the import option in the file menu. Control aliases allows you to choose the names that will be shown for controls in the DDC editor. By default, the editor uses generic names for controls. So for encoders, you've got group A through group D, and then the individual controls within each group are just numbered sequentially. Buttons are the same way. Again, you've got group A through group D. With this file, you can choose the name of each group, as well as the controls within each group if you like. As an example, I've set this file up for the nanoKONTROL 2. So you can see now in the editor, my first encoder group is knobs, the 8 knobs on the controller. Second group is faders, the 8 faders on the controller. And the last 2 groups are listed as unused because the controller doesn't need them. And then for buttons, I have my solo buttons, mute buttons, and then record buttons, which have no assignment. That's because they're used for page selection. So this is just a reminder to myself that, okay, don't assign anything here because these are used for page selection. Then the last group is labeled as transport. These represent the transport controls on the controller. And notice that each individual control is labeled here. Again, these aren't used for device control. These are going to be used for transport control. And we'll see how that's done with the next file. Transport definitions allows you to use button group D for transport controls. This is intended for use with controllers that have dedicated transport controls, like the nanoKONTROL 2, for example. Here you can see the transport options that you have, and then at the bottom here you can assign what transport function each button should trigger. Now if I go back to live, you can see that I can navigate left and right between tracks. I can toggle the arrangement loop. I can rewind and fast forward, start and stop playback, and toggle session record. Button parameter definitions allows you to use buttons to more precisely control parameters. By default, buttons will typically toggle between the minimum and maximum value of a parameter. For example, here I'm controlling a waveform selection in Diva. Notice that I can only toggle between the first and last waveform. As another example, if I'm controlling a macro, I can simply toggle between the highest and lowest value of the macro. With this file, we can specify which parameters we need more precise control over. In the case of the waveform, there's actually 8 waveforms that we could select between. So we're going to specify 7 here. So why 7 and not 8? Well, the number you specify here is actually 1 less than the number of steps you want. So again, we have 8 waveforms, so we'll specify 7 here. All right, and then for the macro, let's say we want 10 steps. So again, we're going to specify 1 less, so we have 9 here. And now you can see, for the waveform selection, I can toggle between all 8 selections. And for the macro, I can toggle between 10 steps. Display adapter essentially allows you to use a physical or virtual display with a DDC script. The base version of this is meant for Python programmers who want to do their own adaptation. This is what that file looks like, and it simply sets up some observers for the properties of a DDC script. We also have some pre-made variants that you can just drop right in and use. All right, no coding involved. The first is the push display adapter. This can be used with Push's display or any display that can emulate Push's display. An example of an emulation is our application called PDE, or Push Display Emulator. As you can see here, this is an on-screen display that can show the names and values of the first 16 parameters that the encoders are controlling. Another variant is the mativeKONTROL display adapter. This can be used with the mativeKONTROL display or any display that emulates it. One such emulation can be found in the Machine Mark II. And as you can see here, the display shows the names and values of the parameters that the encoders are controlling. Button slider definitions allows you to use a group of buttons to control a single parameter. We call that group of buttons a button slider, and you can have up to 8 of these. In this file here, you simply need to specify the note or CC numbers of the buttons in each button slider. I've set up an example here for the APC Mini. I've got 8 button sliders here, and they're currently controlling macros. Custom encoder element allows you to define specialized behavior for the controls on your controller. This is another file that's meant for Python programmers, but we do have variants that are ready to use. Specifically, we have variants for the encoders on Living Instruments code. This allows the LED rings of the encoders to be dynamically tailored to the parameter that they're controlling. If they're controlling a continuous parameter, you'll have a full LED ring. If they're controlling a center detented parameter, you'll have a bipolar LED ring. And if they're controlling a quantized parameter, such as a filter type chooser, then you'll have a discrete LED readout. Also, pressing down on the encoder will reset the parameter value, or toggle between values in the case of a quantized parameter. LED output transformer allows you to customize the MIDI messages that are sent to a controller in order to light up its LEDs. This is another file that's intended for Python programmers, but we do have a variant that's ready to use, and that's for working with HSB LEDs on Native Instruments controllers. Here I've got machine mark 2 and I've got its pad set up in HSB mode. Alright, so as you can see, the pads actually work, they control parameters, but notice that their LEDs aren't lighting up. This is because, by default, DDC scripts aren't set up to send out HSB values. When we put the transformer in place, though, now we can properly make use of HSB LEDs.